All right, new day and another laptop that needs to be saved, and this time we have a Dell XPS 9510 edition, which is like a 2021. The customer brought this in locally and said that the laptop no longer turned on. I think it's a bad motherboard or something like that. But they also want me to replace the palm rest while they're at it. It looks like it's falling apart. So we're gonna go ahead and while we have this apart, we'll replace the palm rest. But I haven't taken a look at this yet. We'll take a look together and see if we can get this figured out. All right, the first thing we're gonna do is see if it turns on. And I'm not seeing any lights or anything. And yes, you can actually see this palm rest is coming apart. Even the power button looks a little bit depressed. Maybe someone's been pressing it really hard. We have the power meter up right here. I'm gonna plug this in and see if we get any current draw. So we are getting a 20 volt negotiation. So the way USB-C works is it starts at 5 volts. When you plug it into the laptop, it will negotiate up to 20 volts and then it will start pulling current. Now the current that we're pulling is 0.02, so 23 milliamps. And that's enough to actually turn on the LDO, which is the linear voltage regulator that turns on the EC chip. And the EC chip is a microcontroller that's monitoring our power button presses, which it's doing nothing here. So this could be a number of different things. I'm not 100% sure what would be causing this right off the bat, but it could be a firmware issue. We could actually have a issue with the board. I don't have a full story about like whether they opened this up and we're changing something out, but it looks like all three of the ports are doing the exact same thing. So let me get this bottom taken off and then we can take a look inside. All right, and the bottom just kind of fell off. Usually, if you've seen me open these in the past, they are very, very hard to open, especially for the first time. So definitely somebody has been in here. I mean, the palm rest is falling apart, so that's not helping it stay together or anything. I do also see a huge dent here on the side. So the machine's been dropped. Ooh, and there's a smell in here. I'm not sure what it is exactly. I don't think it's burnt components or anything, but take a quick look around while we have it open. This is going to be the main battery. It's a Dell Genuine, has a serial number there. Here's the NVMe drive, and I think there is a drive in there. That's the heat sinks on there. 2 sticks of memory, 2 fans, and the GPU and CPU are right here in the middle. We can probably start with just doing a CMOS reset on this machine. The way a CMOS reset happens is sometimes you have like a frozen BIOS and you can get this symptom where it won't turn on. Basically, you need to unplug all the power from the system and then it will rewrite the EC chip. Wait a minute. I just found this screw sitting here and I did not take the screw out, and this is one of the screws from in here, so I'm wondering if it was actually rattling around in there. So that's just something to take a note of. Anyway, so we're going to do the CMOS reset. So when we unplug the main battery and take all the power from the system, the BIOS actually has an EC region. Embedded controller is what EC stands for, by the way. And it will rewrite the EC chip, which is that microcontroller that's monitoring the power button presses. And if that code was corrupted because it was in a frozen state or a corrupted state, this will rewrite it. But there's still a chance that even the main BIOS is messed up on this. So we have this unplugged. I'm just going to press the power button just for a few seconds. That will discharge all the capacitors on the board, and then we can try again. All right, so it's discharged. Now, without plugging the main battery back in, I just want to plug the power in. I want to see what it does. It should actually turn on and start pulling current. Now, we're looking here, we're getting the exact same measurement, 0.23, right? So the normal operation, whenever I plug this in, would jump up to like 1 amp, start moving around, then drop down to 0, then go back up to 1.5 amps, start moving around and actually doing things. The fact that it's just sitting there at 0.23 tells me that we have something else going on, and I'm not really sure if it's firmware yet or not. And here's some fuzz. Some stuff that we can send over to the Gooch collector, I guess. It's a small amount though, so we need to collect a larger amount to send over to him. So what I want to start out first is I want to see if we are getting any of the main power rails. We are negotiating that 20 volts, like I said. And over in this area is where the main power rail on this board is generated. And so we have 2 USB-C ports here. That goes to the PD controller here. This PD controller stands for power delivery. That's going to be what's negotiating at 20 volts. Then we have 2 different 20 volt power gates of some sort that have to trigger on and allow the 20 volts to flow over to this MOSFET here. And then this MOSFET's going to take that 20 volts and reduce it down to 12.6, which is going to be the battery voltage on this board. So it's going to be the main power rail voltage. And so it will be pulsing the gate on that MOSFET in order to reduce that voltage down. And so what we want to see on one side of this is 20 volts, and on the other side we want to see 12.6. So let's check to see if we are getting that. All right, so here are those USB-C ports we were talking about, and here's that PD controller. This one actually handles 2 ports in one. And then these are the 2, ooh, okay, is that liquid damage? Each one of these, the 20 volts will come here and then go out once per port, but I think we have some corrosion here. So this could be an issue. Now, if this one was messed up, only one of the ports wouldn't work. But if we see water damage here or liquid damage here, then we must have more. Yeah, you can see it all over here. So I'm assuming we have corrosion on the backside of this board here. You see corrosion here. So this may be a liquid damage situation. I'm not a big fan of liquid damage boards just because you are chasing down a lot of issues and you're having to replace a lot of chips sometimes. But let's take our measurements, like I said. So I'm going to plug the USB-C power in, and then we're just going to take some measurements. So in voltage mode, this port that's plugged into right now goes to this one, and then it's going to come out of this one. There we go. And so we should have 20 volts there. And then this is the MOSFET that will reduce the 20 volts down to 12.6. So one side should have 20, and we have our 20, and this side should have 12.6. And we have 0. So our issue is that we're not actually getting our main power rail being produced. So the odds are on this machine, it probably will run off of the battery, but I am concerned with all this corrosion that we're seeing. This area right here is the AC detect. It detects whether the AC adapter is plugged in or not. There's corrosion all right here. I'm assuming there's corrosion on the other side of the board. I don't want to clean any of this stuff off because I want to see where all the corrosion is. So I think our next plan of action will be to pull this board out and do a physical inspection. We can't really proceed to start trying to fix the machine, but we have diagnosed that the main power rail is missing. And I would hate to actually plug in a charged battery into this board and try to power it on if we know that there's a bunch of corrosion on the board, so because we may end up burning out something. So I'm going to pull this board out, and then we can do a full physical inspection, and we can replace any components that are damaged or clean the board, and then we'll proceed. All right, under the battery, we are seeing some more liquid signs. You can kind of see right here, and that lines up, it corresponds with the touchpad. And so it looks like there must have been some liquid dumped onto the top on the touchpad area, and it must have leaked through. So I'm assuming we're gonna have a lot more corrosion on the motherboard side. Gosh, it's crazy, the touchpad has fallen apart completely. All right, and the motherboard is out. Let's see if we can see any more signs of liquid damage. I wanna look in this area just on the keyboard. We got something going on here. The motherboard was actually fused or stuck to this for some reason. And this isn't even plugged in. That's the backlight for the keyboard. I'm not seeing any liquid damage on the daughter board. But this is definitely evidence that there was a spill here. And I don't know if anyone's taken this apart to clean it, but you know, we're gonna be replacing this whole touchpad anyway. And what do we have here? That looks very corrosive. What are we thinking, milk? What do we think? Let me get everything else taken off this board because I want to get the heatsink off. I want to get this other heatsink off, pull the fan off. We need to do a full inspection, and I'd rather do it all at once. So this is just covering the chipset. It's a heatsink for the chipset. All right, heatsink is off, and we're just looking. This does look like probably the original thermal paste. I'm looking at the pattern, and it's pretty dry, so it needs to be changed out anyway. So we will do that if we can get this board working. Now the main power rail cannot be produced for many reasons. There is a safety mechanism on these machines that if it detects a short, it will turn off the MOSFETs that try to produce that. And so that's what the power management chip is for. But it could also be some other reasons. So this is just a plastic cover that prevents the motherboard from shorting out to the palm rest. So we'll put it back on when we're done. And I'm actually surprised I'm not seeing more corrosion. So, I mean, yeah, we see it in this USB-C port, but I don't think that will prevent the board from, you know, getting the 20 volts. There's something going on here. Yeah, that's definitely burned. So that will prevent it from turning on. You see this resistor is gone right here. So we'll have to replace those. Right now we're just taking notes. So this is the power management chip. This is what's in charge of turning on and off the MOSFETs, charging the battery, things like that. And so we actually could have a bad power management chip. So it looks like the spill's mainly on this one side. But we're gonna go through this whole board. There's the BIOS chip right here in the middle. We also want to check to see if there's any evidence that it has been taken apart in the past and any tool marks. But this looks like it's going to be a spill repair. So this is the EC chip over here. This is what we were talking about doing the CMOS reset. Whenever we have a frozen BIOS or EC chip, is these will get corrupted, and then these will automatically reprogram themselves whenever you do a CMOS reset, unplug all the power. Because the BIOS chip here will actually have a portion of it that is the EC region, and then it will write it back over to this EC chip when it turns it on, which is a really good design. Some of the other models, this is only programmed once, and if this bricks itself, then the whole board's a brick, and then you have to manually rewrite it. And you guys have seen me do this in the past. Here's the PD controller for this other side. It's a little bit different because it only has one port that's covered in this stuff too. So that would actually be in charge of running this, negotiating the 20 volts. But it's crazy that we have both these ports have, looks like milk on it, but I'm only seeing it on that one side. Here's the 3 volt and the 5 volt power rails. Those are going to be the coils for the output, and this is going to be the driver chip right here, and then these are the other MOSFETs that go with it. So I think that's 3 volts and that's 5 volts. But those won't be up and running if we don't have the main power rail. So we need to get the main power rail going first. Something sticky right there. That's the PCH, or the chipset. And now we're back to the other side, and that's that MOSFET that we want to produce the main power rail with. So I'm going to, we could probably clean that, and I bet that will be okay. What I think actually is the problem is this right here. I'm not sure what this circuit does, but you see how it comes over here? Because this is, I think, the 20 volt line, and without this, it won't actually turn on that chip. So let's, okay, I'm gonna plug in our USB-C, and that way we can measure what's over there. But the power management chip should be receiving 20 volts on that big trace. So we should have 20 volts right here, and we do have 20 volts. So this is actually energized with 20 volts. And then this one should be 20 volts also, it is. This one should be 5 volts. It's not. And this one should be 3.7 volts, it is. Okay, so why aren't we not getting 5 volts here? We're only getting 0.9. So without 5 volts on this pin right here, which is VDD, we will not have this chip be able to produce that main power rail. I'm assuming this has something to do with it. It might be a voltage divider that produces it. Yeah, 0.9. Yeah, so this is some sort of voltage divider that produces that. And this is burned up. So let's get these components cleaned up. Let's get this replaced, and then see if we can get that 5 volts to show up on VDD to turn this chip on and get it going. So I'm going to start by grabbing a toothbrush and 91% isopropyl alcohol. We'll just get that cleaned up as much as we can. And we don't have any voltage in the board right now, so I'm just going to measure across this resistor, which does look burned to me. And we're measuring 78 kiloohms. Now we are in circuit, so it doesn't mean that we're going to measure anything that is the chip itself, but if it's low enough, usually you can measure right across it. And this one's measuring 100K. Neither one of those values seem right, and this one did look burned to me. But now that we cleaned it, I want to see if it does anything different, so let's plug it back in. And now we're getting 4 volts there. Now we're getting our 5 volts. That's funny. So the corrosion was actually messing with it. I still want to replace those. Oh, and the thing's turning on. Whew, I felt it. So that's funny. So all we needed to do was just clean the corrosion off of that point, and the board would actually start turning on. We can look at that again. So keep an eye on the power meter. I'm gonna have my finger on the CPU, and now it's pulling an 1.5 amps, like I said, 2 amps, and it got hot, so it burned my hand. So it's funny because, like, you know, if someone else just saw this board, they would say, okay, well, this corrosion, let's clean all this stuff up, and it fixed it, you know. But why did it fix it? Well, we know why that chip wasn't coming on at this point, right? Because we know that we were missing the 5 volts on VDD, and that those resistors is what was actually producing that. But I want to go ahead and replace those, right? Because they didn't look that good. And we'll finish cleaning up the rest of the corrosion here, and hopefully this board will be all fixed up. I'll probably end up, yeah, I'm going to send it through our ultrasonic cleaner too. That way it will look brand new, and if we missed any spots, it will clean the rest of that corrosion off and not allow it to grow any in the future. But let's grab a donor board. Let's get those 2 resistors replaced, because I don't know what those values are, and I don't need to know those values, luckily, because I have plenty of donor boards. And this is the 9510, so let me grab a 9510 board. Here are my 9500, 9510 boards. So here's a match. I've already stolen components off of this board. You can see that we're missing a bunch of stuff from over here, but I doubt that I took anything over near the power management, besides probably the power management chip. No, power management chip's still on there, but we can compare. So that's what we're going to replace. And here are our pretty new resistors here. I just want to measure them, see what we're measuring in line, in circuit. 78K, 111K, 115K. I mean, you know, like I said, anyway, it's in circuit, so there's going to be other stuff that you're measuring kind of around it, so it doesn't really matter. And I wish I would have measured this while it still had corrosion on it, because we know the value is now different because it is actually coming up. So let's remove those two right there. We'll put the new ones on, and then we'll finish cleaning the corrosion everywhere else, and then I'll send it through the ultrasonic cleaner, which let me go ahead and get that warmed up. Okay, so I'm heating up the ultrasonic cleaner. Let's get these removed. So we do 450 degrees C at 60% air. These are small components, so you really don't even need that much heat, but I like to get in there and get out of there fast. I didn't even add flux to take it off, but we are going to add flux when we put it back on. And some fresh solder. Yeah, and this does look like it might be a voltage divider of some sort. I'm not sure because I don't have the schematic on this. Okay, let's grab those new components. Should we measure what these are now? I'm kind of interested to know what the values are on these actually. So we're still in ohms mode. Things are tiny, so they're hard to kind of hold down on. 150K. Kind of a weird value. Okay. What about this one? 100K. 100K and 150K. I guess if we did the math on that, it might come out to about 5 volts off of 20. All right, so let's grab new ones. And when I pull these off, I want to make sure I know which one's which. Okay, so I put them over here. So I'm going to do this one first. And these are small chips, they will blow away with this air pressure. So what I want to do is I'm going to heat this up, get it where it's tacky, and then I'm going to let it cool off and see if I can get the hold there. Try it again. I need to hold this a little bit lower. There we go. There we go. And we want the solder to hold it with surface tension. So we got that one on there. Let me grab the other one. And so the solder should be holding this one so it doesn't blow away. Now we'll add some flux, and it will straighten these out by itself. Like magic. There we go. Just some happy little resistors. This one's a little crooked, but it's okay. These are super tiny. Here's my fingernail. Whew, burn my finger. Okay, we got that cleaned up. And let's clean up this area too. And the thing about corrosion is it's something that can kind of grow over time. So this might have happened to them. They might have spilled on here like, I don't know, 4 months ago or something, and then it's finally starting to get thick enough to cause an issue. They might have even opened it up and cleaned it. And I don't know what it is. Looks like milk, right? What do you think? All right, those were the main areas that we were concerned with, that we saw that there was actually liquid damage. But because we're going to throw this through the ultrasonic cleaner, it's going to clean all the rest of the areas. But we want to make sure we take off all these stickers, because any stickers going through the ultrasonic cleaner actually causes issues. So we're going to take those off. We're going to try to remember where they go. Okay, all the rest of these can actually stay on here. We just don't want to have anything thick. And the last thing we need is to take off any of the heatsink compound, because you can't have any of that in there, or else it will get in the water and then start getting underneath all the BGA chips. So isopropyl alcohol, there's a paper towel here, we'll just scrub it off. Oh, it's hard. It's been on there for a while, 3 years, I guess. All right, got all that cleaned off. And the last thing I want to do is take these little cage covers off. These are for the Thunderbolt. They're just RF shields, but I'm going to take these off and get those out of the way. All right, so now we have the board completely prepped to go in the ultrasonic cleaner. And let me show you how we do that. All right, so I already have this preheated up to 60 C. I can't find the basket for this ultrasonic cleaner, so I'm just going to put a zip tie in here, and we're just going to set this in here, and we're going to put it in for 2 minutes this direction and then 2 minutes this direction, and then I'll show you what it looks like when we're done. So I'm gonna go ahead and pull this thing out. It's been in here for 2 minutes and on each side. And I can't find the basket. Normally there's a basket in here that I'd pull it out. So I'm just gonna pull it out like this. And because there's water, it's distilled water in this solution, I'm just gonna douse it in this alcohol, and that will help displace the water so we can get it out of all the crevices. And so after I complete this alcohol bath, I'm actually gonna blow dry it and I'll heat dry it, and then we can reassemble and test. All right, got the board clean. It's all dried off. It almost looks brand new at this point. Let's look at those areas and see if it cleaned off anything extra. Now, the USB port still looks a little dirty, and I could scrape that a little bit more. Yeah, it looks like it's flaking off. So it did break it up a little bit. So we can finish cleaning off the rest of that. Now, it was only on the surface. Inside the port actually looks okay. See that? Looks brand new. So it was only on the surface there, which I thought was kind of strange. All right, so keep an eye on the power meter there, and I'm gonna put my finger on the CPU, so I will see if it actually starts booting up. 0.2 for a second, right? That's what it was doing before. And then now it should trigger on 0.05, and then we should start getting about an amp. There it is, amp and a half, 2 amps. So that was going through the process of programming the EC chip. So it sat there for a little bit, going through and processing it. And once it was programmed, then it started booting up using that routine that was written into the EC chip. So let's put the stickers back on. I'm gonna reassemble, put new thermal paste on here, and then hopefully this thing will post and we can get this back to our customer. All right, so I only have the motherboard partially installed in here. The goal of this is just to see if we can get it to post, get the Dell screen, because we still got to replace the palm rest, and so I don't want to reassemble this whole thing just to take it back apart again. All right, everything is connected just enough for us to turn it on. Let's plug in the power. Keep an eye on the power meter. So there's that 0.02, and then see it jump to the 0.057. We have a charge light, we have a Dell screen. I want to wait until we actually get to the secured with safe Dell BIOS screen, because that's when it does the final full CMOS reset. See, it turned back off again, and it should come back on. And we are pulling amps, but we're not getting a Dell screen. I'm actually getting a light Dell screen, which is not good usually when that happens. I can see it's really faded here, but it is coming back on. It still might be going through that startup process from the CMOS reset. It will turn on and off a few times, so let's let it run through these cycles. It turned back off again. Should come back on by itself. There we go. Oh, there we go. We got past that. So we got the CMOS reset happened. Keyboard is not working and doesn't have touchscreen. But all this needs to be replaced anyway. So let's go grab a new palm rest and keyboard assembly from the warehouse real quick. All right, so we'll just go out in my warehouse here. I have more than 500,000 parts in this warehouse. Like, these are all motherboards on this side right here. Where we're going to is going to be 03. So here's our third shelf, and then we're looking for 9500. These are all in order by part number. Well, it looks like we have a whole box of them up here. I'm gonna have to go get a ladder. Okay, got myself a step stool. So yeah, here's a whole case of them. And here we go. So let's grab that and we can get that taken back and get it installed. All right, got the new palm rest. So this is actually one that's gonna be classified as like a refurbished condition. When we get these from Dell, they're either gonna be brand new or they're gonna be refurbished. So this may be some sort of open package. It looks pretty flawless to me. So we'll need to transfer everything over to this. If you notice, there's gonna be missing speakers. The touchpad's in there already. We have the junction board. We have the keyboard connection. The Wi-Fi antennas are already on there. The power button's already on there. So it looks like mainly just the speakers are what we need to transfer over, but let's get everything pulled apart again. All right, the motherboard's out. We won't need that. We just need these speakers. And then we need this little junction board. And the power button's already on the other one. And let's unbolt the screen because we'll need to transfer that over too. Okay, so I'm just gonna open this up. That will bend the hinges open a little bit, and then now I can slide this out. And so here's their old junky beat up one. The keyboard's falling apart. The touchpad's falling apart. All right, we'll do more final cleaning at the end. I just wanted to get a little of that dirt off of there. So let's line that up there. And we will need to attach the hinges back, but we did bend them open, so we'll have to kind of bend this back open just to attach a couple screws. All right, now I can lay it back down. All right, the hinges are attached. We will attach these speakers. And then we put this daughter board back in here. All right, everything is transferred over. The motherboard is completely fully assembled. All the stickers are back on it. It has new thermal paste. It's all cleaned out. So when we put this back in, everything should work perfectly. All right, I'll finish putting this back together and we'll come right back. All right, the laptop is all back together. We'll do our final testing. We do have the Dell screen. Keyboard looks nice and new. All right, so we did get the time and date screen. It's not very bright. Let's see if we can brighten it up. Yep, the keyboard's working. I'm able to select the BIOS settings here. And let's see if we can go to the BIOS. All right, perfect. Let's see if it will boot into their operating system. Not sure what it's doing. It keeps going to a blank screen. Let me shut it back off. Let's boot into diagnostics instead. I don't know if they actually have an operating system installed on their SSD. So we're running diagnostics. What I'm looking for is any errors that show up. It's going to test all the devices. I also want to check to make sure the battery's charging and that I can run off the battery. And if everything passes, we'll be able to get this back to our customer. And I'll talk to them about their SSD and see if they're having an issue with that install. All right, it passed all the diags. It charges the battery. The battery's in fair condition, so maybe they want to replace it. I'll talk to them about that. It runs off the battery and it boots up to their operating system. So this wraps this one up. I hope you found this interesting. I'd love to know your thoughts on this one, and thanks for watching.
I saved another laptop!